Dear students, now I am going to explain about normal forms based on primary keys. Already in the previous class, we have discussed about the functional dependencies. Okay, so now we are going to discuss about how the normal forms should be defined based on the keys and functional dependency. With that, we are going to see first normal form, second normal form, and third normal form. Remaining BCNF, fourth normal form and fifth normal form in the another section. Okay. First, we have to see normalization. From the name itself, it is there. It is a normalization, normalizing the relation. That means the process of decomposing unsatisfactory bad relations by breaking up their attributes into smaller relations. That means we are converting that bad relations into good relations. 100% we can't convert that. This, at least some extent we are making that bad relations we are converting into good relations. How we can make it? Breaking that is decomposing that bad relations into two good relations, multiple good relations, and so on. Okay, so here what we are going to do means that in order to define that normalization process, we should know we are defining the help of function dependencies and primary keys. Okay, so what is the desirable properties of normalization is main thing is minimizing redundancy and minimizing insertion, deletion and updation anomalies. These are the main properties of the normalization process, main purpose of normalization process. Only we can minimize redundancy and insertion, deletion, updation anomalies, not completely avoiding. Okay, that is only we can do it. So it can be considered as a filtering or purification process. Otherwise, we can call this as a normalization process as a filtering or purification process. So first we are going to see this conditions using keys and functional dependencies of a relation to certify whether a relation schema is particular normal form. So first we are having second normal form, third normal form and BCNF. This is based on keys and functional dependencies both. Fourth normal form we know it is based on only multi-value dependencies. Fifth normal form is based on joint dependencies. So additional properties like task dependency preservation next we are going to discuss. So first we are going to do normalization of relations. First we should know lossless join or non-additive join property. Because during the normalization process we are going to split the relation, bad relation into two sub-relations. So in that thing, when after that again we are going to join that relation, it should be a lossless join. That means guarantees that the spurious tuples will not be generated. After splitting, again we are going to join with the help of natural join. It should not generate spurious tuples. That is the main thing. And the dependency preservation property is it should ensure that each functional dependency is represented in some individual relation resulting after decomposition. Okay, so that is a dependency preservation property. It has to preserve the what dependency it is there, function dependency or whatever it is there, that it has to preserve. And then that is normalization is carried out with this not to meet these desirable properties, minimizing redundancy, minimizing insertion, deletion and updation anomalies. So normally the database designers need to normalize to the highest possible normal form, that is up to third normal form. Okay, up to third normal form. Sometimes it will be in BCNF and at most fourth normal form. So denormalization and also the normalization we know. Now next we have to define what is meant by denormalization. The process of storing the join of higher normal form relations as a base relation which is in lower normal form. That is the opposite to normalization process. So in order to define the normalization is a step-by-step process. In that each step is called as a normal form. In order to define the normal forms, first we should know the different types of keys. Already we have discussed the different types of keys in the second module like super keys, candidate key, all those things. So again we are going to revise that. First we should define a super key. Already we know a super key of a relation schema R is equal to A1, A2, etc. An is a set of attributes S, subset of R with the property that no two tuples T1 and T2 in any legal relation, should be a legal relation, state R of R will have T1 of S is equal to T2 of S. Okay. So that is So from that is a super key. For example, if we'll take that SSN of an employee, that is a super key. So that will be unique for each and every employee, every tuple present in the employee relation. And SSN and name together will take also, that is also unique. And SSN, e-name, the employee name and birth date, all three also it will be unique for employees together. So now we are having the different types of super keys like SSN, comma e-name, SSN, comma e-name, comma date of birth, SSN, comma address, and so on. Okay, these are all the super keys. So now we should define what is mean by key. A key, K is it should be a super key. First of all, K should be a super key with additional property. Removal of any attribute from K will cause K not to be a super key. That means the minimal super key is called as a key. Okay, in the super key, if you are going to remove any attribute, again it should not be a super key, mean that is a key. Okay, for example, if you take this super keys SSN, comma e-name, SSN, comma e-name, comma birth date, all those things, here we will remove that SSN, it is not a super key. If you will remove here also this is not super key. Among these three, which is minimal, this is only minimal. So SSN is a key. Okay, then next we should define candidate key. If relation has more than one key, each is called as a candidate key. Suppose for example, in the company database, we will take employee department relation. In the department relation, department name and number both will be unique. Both are minimal super keys. So that is both are called as key. So in this we will call it as a candidate key. Among the two keys, in the department number and department name, any one will take it as a primary key, another one will be the secondary key. Suppose for example, department number is a primary key, means name will be the secondary key. If name is a primary key, means number will be the secondary key. Okay, so that is a thing. So that we have taken that example. And then prime attribute. So prime attribute must be a member of some candidate key. That member of the candidate key is called as a prime attribute. So the other attributes are called as a non-prime attribute is not a prime attribute. That is not a member of a candidate key. These two things you should know. For example, if SSN and P number are prime attribute of Oxon relation, because that SSN P number together it identifies the tuples in a relation. But whereas the other attributes on Oxon is called as a non-prime attribute. Okay, you should be clear about prime and non-prime attribute. Okay, so the next class we are going to discuss about the different types of normal forms. First normal form, second normal form and third normal form. Okay, so before that be thorough in the different types of keys, super key, candidate key, secondary key, primary key and prime attribute, non-prime attribute. These things you should be thorough, as well as you should know the functional dependency and the different types of functional dependencies. That means full functional dependency, partial functional dependency and transitive functional dependency. That concepts you should be thorough. Then we can go for a normal forms one by one. Okay, so